All right. Okay. Let's go here. On my notes. Okay. All right. So I'm just going to talk a bit about like why you should use Node and what situation you should use it. Not like a promotional talk like use Node for everything, but more of a when you want to ask a question, what you should use it for. Here's an answer. So if you want to assess the priorities and opportunities afforded to you by the platform or of a community, it's best if you begin with the reason why it was ever created. And so for Node.js, like you'll need to know a little bit about Ryan Dahl. One, he doesn't like JavaScript at all, really. He much prefers C. Two is that he doesn't much like programming. He just likes making things. And the easiest way to do that is always his favorite way. And three is that he writes servers, and he's always written servers and he'll always write servers. So somewhere along the way, Ryan used to write servers in Ruby and then made them very fast, and then kind of decided that Ruby was the problem with making servers fast. And so he basically started building this toolchain of C just for writing his own high-performance, high-concurrency servers. And this sort of like C toolkit, the HTTP parser and the non-blocking C APIs and the first versions of Node are actually from that toolkit. And at some point after writing servers in C for a long time, he realized there was just way too much programming and verbosity to write servers in C. And so he started looking at an SVM to bind it to. And what he really wanted was great closures. Closures make a lot of the pain of callbacks subside if you use them, right? So he found DA, impressed by it, and now we have Node.js. So there's sort of the birth. But Node.js was built for writing servers very, very quickly. Node is good right now at building servers very quickly. If you try to build something that is not a server, you likely could have done it better in another platform. So as Node's evolved, it's become easier and easier to build a lot of things fast. And I'll give you an example here to like whet your beak a bit. I need to do the fancy sharing though. Where is it? Conversations, share screen, start. Yeah, now it's like looping forever. Okay, so here's a little bit of code. So this is a full HTTP proxy. We create an HTTP server, we give it this callback here with the request and response object. We take the request object, we pipe it to this request library here, which is a high-level HTTP client. We create a request instance for the URL that was passed into us. When you enable a proxy in curl or in your browser, the path is actually the full HTTP URL, if you didn't know that. And then this is actually returned by pipe. The destination is returned. And so we then pipe that to the HTTP response. And then we listen on 8000. And this is a full HTTP proxy that you can enable in your browser. And it's quite fast. It's actually comparable in performance to Nginx. And depending on how you look at it and which benchmarks you want to do, it's above or below. It will always use a little bit more memory than Nginx because it's JavaScript and not just C. But yeah, so that's that first example. And let me switch back over here out of fancy mode. There we go. Okay. So let's get back to my notes for a second. All right, that's useful. You're probably thinking, like, who cares? I don't write web proxies. I write web apps. Rails, motherfucker! You're unlikely to want to leave your tools that are building web apps very well. So here's something that's a little bit more relevant. Let me pull back into the stupid screen sharing thing. All right, start. Okay, so this here, oh, you can't see it? Can you see it now?
No. There we go.
Yeah. All right. Takes a little second to catch up, I think. Okay, so this is very similar to the previous example, but here we create a request object for just the path that comes in. This isn't a full HTTP proxy. This is going to take every request that comes to our server and it's going to send it to a bucket in S3. And then you just get this little line here that sort of enables it. So this isn't something that you want to stand up, but there are a lot of requests in your application where you end up just going, I'm going to pull this out of S3, I'm going to send it to S3. the important point to note about a request here is that it knows about its inputs and outputs. So the headers that come in and out, it's not just taking the body of the request and sending it chunk by chunk to the destination and sending the same for the response coming back. It's actually pulling off the headers as well. So yeah, this is just a very, very nice, clean proxy. And it's quite fast, and it's really the most efficient way that you could build a load proxy in any platform. So the really important thing to know about these streaming examples is what they imply for mobile. So mobile throws a big wrench into the concurrency problems that already existed in Ruby and Python and a lot of other platforms, and even still exist in a lot of the coroutine and non-blocking libraries for both. So when a client is too slow to continue taking data, it sends a TCP signal that says, I can't take data anymore. The kernel won't just let you keep writing data and like overflowing. You have to buffer that into memory. And in blocking I/O, you just sit there and wait. And in a lot of coroutine libraries, you actually just keep taking it into memory because you don't have a way to pause the input. So the only people that really do this right are Node and Erlang. And they do it entirely differently. But in Node, the stream examples where you pipe one stream to another, there's logic that waits for that TCP signal, and then it'll pause the input. So if there's a file coming off a disk, it'll stop requesting chunks off of the disk. And if it's a remote S3 HTTP client, it'll actually send that same TCP signal and say, don't send me any more data. So the memory footprint per connection for slow clients is very, very low. We're not keeping any data in memory that we don't need to necessarily. And these kind of features are really, really typical of high-performance servers like Nginx and ATA proxy, but they're not very common in application platforms. So now, yeah, hello? Check the video?
Yeah. Sorry to hear your
So I see me, and then I see a screenshot of you that's not moving any longer. I muted it and then did it again, and see if that helps.
Oh, there you go. Yay.
Alright.
What? Alright. We can see it, that's all that matters. Carry on.
Okay, alright. Okay, so should you use Node? When should you use Node? Node is an application platform for building servers. So if your application needs to use Node. Node's timing was really good. A lot of new modern applications actually need to be servers. So if your relationship with the internet and your own infrastructure are limited, like a Rails app that talks to one database, it takes and it just keeps you setting whether it gets or puts the database. You really don't need Node. Rails is actually for that, the perfect fit for that. Or Django or whatever the hell else you want to use. MVC frameworks are really helpful for that. But if you're talking to Redis and React, Postgres and Facebook, and Apple's silly push notification server, then the number of I/O operations you need to do for a single request really scale with the application process in Python, and then it's exacerbated by code. So if you notice yourself leaning really heavily on message queues for what seem like really simple like application tasks, the platform probably just isn't a great fit. You're sort of working around a lot of the problems of concurrency and trying really hard not to be a server when really you need to be a server. Talking to I/O sources is the job of servers, so that's what you use Node for. Anything else is going to be painful. Except maybe Erlang, if you want to tackle the Erlang monster. And that's all I've really got. And if I didn't piss people off too much, I'll take some questions. Although I can't see you guys anymore, I just see Aim's face.
Yeah, sorry, the bandwidth was all over the place there. So I killed the video.
Oh, I see.
But we'll try it again. So, this is the question couch. Go sit on the question couch and ask some questions.
It's alright, I don't play.
You like what I'm saying?
Hiya.
Okay. So Node 4 was stability, Node 6 was Windows, Node 8 would be like isolate. What would you like to see for 1.1 beyond?
So it's not isolates anymore. Isolates got cut.
Domains. Yeah, isolates.
Yeah. I mean, well, domains actually so Node 08 is about debugging. It's about making debugging suck less. So it's not just domains. Domains are a part of it, but there's also a lot of really amazing post-mortem debugging, in particular if you have dtrace. So if you have dtrace, Node has better post-mortem debugging than any application platform on the planet outside of Java. And Java only actually got all of these features like 2 or 3 years ago. So that's all getting way, way better and really phenomenal. After 08 is actually 010, it's not 1.0, so don't assume that 1.0 is coming after 0.9. In 0.10, I know for a fact that we'll be doing this a lot of, it's the last breaking API release that we want to do. We have a lot of APIs that aren't quite solidified, and we may change or break those more in the future, but all of the APIs that have been around for a while that we continue to change and iterate on, those will never change after 010. So we have a huge amount of refactoring to do. Internally in Node, we don't use streams to connect other streams together a lot, and we have a lot of like crazy one-off code to make all this stuff work. We want to get rid of that. Isaac has crazy ideas about bringing the HTTP parser into JavaScript to make everything faster. And I mean, the C parser is quite fast, but there's this penalty with crossing the barrier too much. So yeah, we're considering bringing that in, and also removing some optimizations that we have for not destroying using C parser instances because they take a while to create. Getting rid of that code will get rid of like a lot of memory leaks that we see over time. So really, it's just mainly refactoring. It's just finding all of the things that annoy us right now about the implementation and fixing them now because we don't want to do it again. I mean, I know that Node changes a lot and breaks API a lot and is sort of famous for it, but the crazy thing is that after 1.0, we won't change API again. The API that is there will be there forever. You know, we don't want to be Python and break the whole language to make printf function. Like, we really want this to be something that you can rely on the way that you rely on, you know, tar and gzip. You know, like people don't really worry about the version of tar that they have unless they're a real dork. And that's what we want to do. Yeah.
Hi, Richard here. So one of the really cool things about Node is the NPM ecosystem and the way that it manages versioning between different modules. If you come from having worked with DLL, Hell, or Jar Hell, that's really refreshing. So can you give us an insight into what is the future for NPM specifically? What the plans are?
So Node, I know, so in the earlier days of NPM, and this is sort of faded away, NPM was trying to be a little bit agnostic. You know, it was definitely baked into Node and for Node, but it was definitely trying to be a little bit more server agnostic because it still wasn't clear if Node was going to win, and there were a lot of other competing sort of JavaScript frameworks. That's gone away. And the Node module system has now continued to modify itself to make it work better with NPM. And so there's actually going to be even stronger bundling in the future, I think, between NPM and Node. I don't think that they'll merge into the same repo, just because NPM has a really great group of people that all kind of contribute to it now, and they're not Node core committers, except for Isaac. So, yeah, I think that there will be greater integration. The packages website and the npm.js.org stuff is going to become packages.nodejs.org. You know, it's going to be very, very official, and there's going to be a lot more work put into the community side of the package management system. I think in terms of technology, we're learning a lot more every day. There's some features that I want in particular around. So you run into these problems when you start checking all your packages in the Git. So you should actually do this. If you're deploying something, all of your dependencies should just be checked into Git. You shouldn't rely on like an npm rebuild every time you deploy. Just check them into Git. It's like great. It's literally the best thing you can do. But you hit a few really annoying things. Like when you want to upgrade a single package for all of its dependencies, it becomes very, very difficult. And the trees get really, really big. And so there's like an npm flatten command, and there's a few other things that we really want to do to make some of these use cases work a little bit smoother. But npm has reached like a really good point of maturity. And it's more mature than some areas of Node, actually. So I wouldn't expect too many huge changes in npm in the future, except, you know, some more modules.
So I'm just gonna throw in one more. This is it's not a major issue, but it is something that I have run it, yeah. So I teach a master's course on Node.js and HTML5 apps. About half the students, of course, are on Windows. And when they start using NPM and using modules that do compilation of C code, they run into all sorts of problems getting that to work. So, like, do you have some insight into what's going to happen around cross-platform support, or is that just don't use Windows?
It's definitely not don't use Windows. So one thing is that we're trying to make everything more doable in JavaScript and bring more things into JavaScript just to get out of compile modules in general. The other thing is that Node Core, in the last release, underwent a huge change in the way that it actually compiles. And so it was using WAF. And then there was this Node WAF thing that you could use to compile your dependencies, and then it moved to JIP. And so now we're sort of solidifying around a good tool chain to use for doing compilation, and then expect better integration of that into NPM over time. And there's already been a lot of changes to Node JIP to make that work better, and to make module compilation work better. In particular, the way that Node JIP works is that you have these dynamic scripts that don't need Python to run and install on the remote machine, but they basically build out these giant makefiles in Python based on a bunch of variables. And so that reduces the list of dependencies that you need. And yeah, the other thing too is that there's a feature that a lot of people don't know about called npm rebuild. So if you do a new deployment on a new operating system, and you update a dependency that you checked in, or any code that you checked in, you can run an npm rebuild and it will actually force recompile anything that's been compiled previously. And that's just, like an education problem. But yeah, compilation is a problem. I think it's less of a problem in Node as it is in, say, Ruby or Python or other languages, mainly because most of the C libraries that you want to bind to use blocking I/O, and so you can't use them anyway. So we ended up just writing this whole thing over JavaScript. That's a horrible pain in the ass, but eventually one person does it and then we're good. I mean, this has happened with Postgres, it happened with Redis, it's happened with all of the big libraries. So.
Yeah, I mean, the main library is the MongoDB one.
Yeah, MongoDB definitely uses synchronous I/O. So there's like multiple parsers now in JavaScript, and there's even like a whole ODM that the Learn Boost guys wrote called Mongoose for MongoDB specifically.
Okay, cool.
No problem.
Anybody else? I don't think it's like.
You don't want to go and ask I can't even fight back, I'm a humble.
Well, I already gave everyone here a description about why I don't like what happens to the Unix socket diagram support. I saw you were a proponent of the other side, but I don't want to maybe want to turn on.
The fact that it went away for a second and then it came back, or?
It came back.
There should be. Yeah, we're not going to never do UDP. That's not going to happen.
No, not UDP, Unix socket diagrams.
Oh, yes. So, yeah. It's not that it's not going to come back, it's that we need to find a way to do it. Like, we need to find a way to do it that works, not necessarily on Windows, but if it can't work on Windows and there's literally no way to do it, then what we really need to do is find a place to put APIs like that, and find a way to essentially discourage them.
Okay. I feel like Python does this correctly. If you try to create a Unix socket on Windows and just say that that doesn't exist, you can't do that. I feel like it's probably the right way to do it.
Right, but the way that Python implements sockets is to basically write POSIX sockets and then port them badly to Windows. We don't do that. Right? Like we have like a notion of non-blocking sockets in WV that try to map well to every operating system, and so it's a harder problem. I do agree that it does need to go back. I mean, we need to have every feature that is available to that network player. There's also a third option that is way in the distant future, but there are now a couple networking drivers that will basically memory map the network hardware right into your application memory space. So this means that we bypass the kernel entirely and we talk directly to the device drivers. So we'd have to re-implement TCP and redo it all in JavaScript. But it's an order of magnitude performance increase over talking to the kernel because we get out of 2 NodeConfs. So it potentially in the future there may be an optimization or a mode in Node where it won't even use the kernel socket or network layer at all. This is sort of our future stuff. But the day that we do that, I know server beats HA proxy and Nginx by 3 or 4.
Well, if there's no other questions, speak now. Do you have any questions? My question would be, can we do this again sometime?
Oh, okay. I mean, is that an invitation to your home? Or?
There's stuff that you can see. No, listen, Michael, thanks very much. Really appreciate it. Sorry I didn't make it to Concurrency.
That's great.
Did it go well?
Yeah, oh yeah. It was phenomenal.
It looked exhausting, that was the reason I didn't go.
It was exhausting.
Too many bites. Anyway, thank you so much for being part of our first NodeConf meetup. Really appreciate it. And I'll talk to you soon.
Yeah, look forward to it.